Today, we will discuss the two types of frictional forces, kinetic friction and static friction, and how they can be understood and applied to real-life examples. There will be friction, a force acting in opposition to movement, whenever an object or surface tries to slide over another object or surface. The first frictional force that a surface or object will encounter is static friction, which is the initial force that needs to be overcome to get something moving in the first place. The point at which an object moves across another object is when maximum static friction has been achieved, at which point static friction can no longer hold the object in place and allows it to break free and move. Once maximum static friction has been achieved, there is a transition to the second frictional force, kinetic friction. Even though the object is moving, kinetic friction is still acting to oppose that motion. However, this opposition is much lower than what was present in static friction, because both adhesion and abrasion lessen once an object is in motion. The amount of frictional force that an object or surface experiences when in contact with another object or surface can be measured through the coefficient of friction, which is mu equals force divided by normal force. The coefficient of static friction will always be greater than the coefficient of kinetic friction because there are more forces acting to prevent initial movement than there are forces preventing movement once it is already in motion. The amount of static friction present will depend on the kinds of objects in contact with each other and their surfaces. With rough surfaces, there are more irregularities which increase friction. On the flip side, very smooth surfaces have increased friction because of increased electrostatic forces. Moreover, the more forces acting to hold an object in place, the greater resistance to movement. For a real-life example, we can think about tires on a car and the surfaces that they come in contact with. A tire on concrete requires much more applied force from the engine to achieve a maximum static friction than what is required to get tires to move on a wet road, and even more so than what is required when tires are on snow. The coefficient of static friction for tires on concrete is 1, with a kinetic friction coefficient of 0.80. There is a coefficient of static friction for tires on a wet road, 0.60, with a kinetic friction coefficient of 0.40. And finally, there is a coefficient of static friction for tires on snow, which is 0.30, with a kinetic friction coefficient of 0.20. In order to get the tires to move across the concrete, several things have to be considered. First, how much does the car weigh? Plugging this weight into the equation W equals mass times gravity will give you the normal force perpendicular to the concrete. You can then find the maximum static friction, which tells you that the engine must exert a force greater than this in order to achieve movement. Maximum static friction can be found using the equation Fs max, which is maximum static friction, equals the coefficient of static friction times normal force. So in our case, if the car weighed 200 kilograms, the normal force would be 200 kilograms times 9.80 meters per second squared, which is equal to 1,960 newtons. Therefore, with tires on concrete, the engine would have to exert a force greater than 1,960 newtons times our coefficient of static friction, which is 1, which equals a total of 1,960 newtons. The knowledge of static and kinetic friction is important for knowing how to get your car moving, maintain movement, and also how to determine required stopping distance. For example, if friction is cut in half, say from 0.4 to 0.2, braking distance will need to double. If it goes from 0.8 to 0.2, there will be 4 times the amount of distance that will be necessary in order to properly stop. Therefore, knowing friction is important for practical purposes and also for safety purposes. And finally, thank you for taking the time to listen to my presentation. I hope that you made new and exciting connections to what was learned in physics to real-life examples in our everyday life. Thank you.